Hello, everybody. Welcome to NTWC Plus. It is good to see you as we get into late October. A lot of tropical activity going on, and we'll talk more about that later on. I think we've got another terrific program for you today. We'll introduce our guest, Dr. Rosimar Rios-Berrios, in just a couple of minutes. But first, let me introduce Mr. Bill Reed, who is here, former director of the National Hurricane Center. Bill, before we get to our sponsors, I just wanted to say welcome and good morning. And where in the world are you today?
Well, we took a novel approach. We were over here in San Antonio on a 1-week vacation, and about the only way I'd be able to do the show was either set up at a Jim's coffee shop or come over to Alex's house. So here I am in Alex's dining room, coming to you just like as if I was back at home.
In theory, a little quieter than Jim's coffee shop, in theory.
It would have been kind of noisy, I have a feeling.
And the coffee's better at Alex's house anyway, so you're better off. You're better off. Good to see you. It's always good to see you. And let's go ahead and thank our sponsors before we get any farther into this. USAA, great folks. They've been part of our program since the very beginning of this program. So thanks to USAA for all you do and do for what we do at the National Tropical Weather Conference. The South Padre Island Convention and Visitors Bureau once again in for the 2026 conference. Proud to be partners with the SPI CVB. Once again, they're our hosts for the conference, and we really appreciate all they do. Weather Boy, the Weather Company, and Live View, all the folks who make this a possibility each and every week. And we're here from the beginning of hurricane season pretty much till the end, and we're here because of them. We couldn't do it without them. So thank you to all our sponsors who make this a possibility. And Bill, the other thing today is where you are and where I am, and I think probably where Rosimar is as well, Dr. Rios-Berrios, is the weather has changed. We finally got the tropical air mass out of here.
Yeah, I think we've just seen the end of August-tober.
Exactly. So let's have at it. Let's get started with the program. Go ahead, Bill.
Okay, well, it's my pleasure to introduce our guest, Dr. Rosimar Rios-Berrios, is a leading expert in atmospheric science, currently working at UCAR, and she will share insights on some of the cutting-edge research she's involved in. We were talking before we came on, and came to the conclusion that she and I met when she was a student at Mayagüez down in Puerto Rico, where she is from. So welcome, Rosimar.
Thank you. Thank you for having me.
Great. Since even us and most of our viewers probably aren't aware of what all you do, how about if you give us sort of a quick overview of what you are working on?
Sure. Yeah, I am a scientist at the NSF National Center for Atmospheric Research, also known as NCAR. Here in Boulder, Colorado, we're managed by UCAR, as Bill mentioned. And in my job as a scientist, I like to say that I'm behind the scenes, working to improve weather prediction, specifically for hurricanes. Most of my work is related to gaining a better understanding of how hurricanes can become very powerful, but also I'm now going into the direction of understanding how rainfall in hurricanes is produced and how that rainfall may change in light of a future warmer climate.
Oh, wow. That's you're right up my alley there. I had, in my 40-year career, I was personally working for 3 40-inch or greater rainfall events, all, of course, from decaying, really. None of them, Harvey was the only full-fledged hurricane at landfall of the ones that produce that kind of rain. And one of the areas that I've always, and yesterday it came up, I had some questions from people. How much does the lifting of the caused by the orography, say, like Puerto Rico and also in Jamaica, how much does that enhance the rainfall rate in the tropical atmosphere that's brought in with a tropical cyclone?
Yeah, that's a very interesting question. I'd say right off the bat that it's not trivial. We tend to think about very tall mountains in places like Taiwan, for example, an island in the Pacific Ocean with very tall mountains, and we tend to think those are the kind of mountains that make a difference. But it turns out that even subtle mountains, not as tall as in Jamaica or Puerto Rico, that are, barely 1 kilometer, above sea level, even those mountains can help enhance the precipitation. Think about it as the air is already rising. There's plenty of upward motion in a hurricane, right? There's plenty of moisture. So we know that there's going to be a lot of rainfall production. But if on top of that, you add just that teeny tiny extra lift due to mountains, that can cause even stronger vertical motion, more air rising, more water vapor condensing and producing rainfall. So I'd say, it's very difficult to disentangle this in the real atmosphere. This is where numerical weather prediction models can help. So in my work, for example, I've done some studies with the island of Dominica in the Caribbean. For those unfamiliar with Dominica, it's a very small island, but with very tall terrain. And when we do some experiments in the models in which we hypothetically remove the mountains, we just assume that Dominica is just a flat mountain, we get far less rainfall than we would if we take the same experiment with the mountains as tall as Dominica. So I would say it's very difficult to disentangle, what's the hurricane doing, how much is being exacerbated by the mountains. But I'd say with great confidence that mountains, even not very tall mountains, can worsen conditions due to rainfall in hurricanes.
Yeah, I mean, I look at the soundings. It's a deep saturated layer, and the warm process rainfall rates are so incredible. I mean, I had about 3 hours of 5 to 6 inch an hour rainfall rate in Harvey, and it's as flat as your model Dominica, where I live in Galveston County. Is there an upper limit, do you think, to the rainfall rate you can get out of these systems?
That's an interesting question. We tend to think about it in terms of precipitation efficiency. So you need the supply of moisture, but not all of that moisture that rises and condenses is going to fall down. So I would say probably there is a limit out there that is given by conditions like ocean or land temperatures in the case when the hurricanes make landfall, but then that's probably your uppermost limit, the combination of that much moisture and how strong the air is rising in a hurricane. But then there's other processes that bring that down, and other processes could be that there could be some dry air coming in and preventing all of that condensation to fall to the ground. So instead, some of it dries out. So yeah, upper limit is interesting. I think there's definitely an upper limit up there. What is it? I think it changes from condition to condition, from hurricane to hurricane, and even from day to day.
Yeah, we had a tropical storm Allison and unloaded on Houston in 2001. And for very short periods of time, there were a couple of instances of an 8 inch an hour rainfall rate. Thank God it was for a short interval because it was right over the downtown. So, yeah. And there was a lot of discussion after Helene last year that how important the rate that it falls is when it contributes to flash flooding and mudslides. We had that again in the hill country in July. I think there was probably some influence from the remnant moisture from what had been Tropical Storm Barry earlier in the week in there. And it made all the difference in the world, I think, the fact that so much rain fell in a short period of time. Are you working at all on the landslide flash flood aspect of it?
So personally, I'm not working on the landslide or flash flood, but I was part of a project called Prediction of Rainfall Extremes campaign in the Pacific, or PRECIP 2022. And that experiment, it was a field campaign. So we went to Taiwan and Japan with research radars and atmospheric weather balloons and other instruments to understand the ingredients that produce very heavy rain, and that can then trigger high impact or hazardous conditions like flash floods and landslides. And so one comment I wanted to make with respect to your recollection of Allison and other cases is that how much it rains and how much then causes things like flash floods, landslides, road damage, etc., is a function of how hard it rains and for how long, right? So we might have cases like Harvey where it stalled or it was moving very slow. So then you have a lot of rain falling for a very long time. But then you can have other cases where the tropical cyclone may be moving faster, it may be moving at a certain speed, but then it's raining really hard. And I think one misconception that's out there is that it rains harder the stronger the hurricanes.
Oh, yeah.
And I
hear that
think
all the time.
yeah, right. And to some extent, yeah, that can be possible, but it's not always true. Like the case you brought up is like Allison. The other case that comes to my mind was Hurricane Fiona, which was a tropical storm when it crossed near Puerto Rico in 2022. And it still, as a tropical storm, it brought a lot of rainfall. And in that case, it was a function of, it was a tropical storm, but it was raining really, really hard. So it doesn't take a very powerful hurricane to produce a lot of rain. Even weak tropical storms can produce a lot of rain.
Yeah. I've always thought one of the issues with the stronger storms, in the weak tropical storms, the individual cell motion is fairly slow, sometimes 10 to 15 miles an hour maybe, but like a strong, large hurricane, the cells are moving quite rapidly, so they're not over the rain gauge you're trying to measure it in for as long a period of time. So the rainfall, the producing storms are probably just as efficient, it's just they're moving.
Right. Yeah, and then you have the strong winds also blowing the rain away, so it's not all falling where it condenses. It's just
right.
a very three-dimensional process.
Yeah, and then the hydrologists will, of course, chirp in and say, you better also take into account what it's falling on. Is it a very rocky soil with very little absorption of rain, or is it sandy and loamy where it can handle a lot more rain? It is a complicated issue.
It is, and then antecedent conditions too, like are the soils saturated from previous rainfall events? Are they dry because they've been in a drought? It's a very complex issue.
Yeah, to shift gears on you a little bit, because I was fascinated with Melissa when it was barely moving and was very strong. Yet normally when we see that, we start to expect upwelling to cool the fuel, so to speak, and a beginning of a reduction in intensity, and it didn't happen there. And Brian McNulty, I suppose you know of him, but he had posted earlier a graphic that showed how deep the very warm water was, and I guess that's fairly common in September and October, but because we're running a much warmer than normal Caribbean Ocean, it was a very impressive deep water layer. Is that your thinking on the intensity issue as far as upwelling?
Yeah, I definitely agree. Like you, I was also watching Melissa being very strong and barely moving, and like you, I was expecting some weakening, precisely due to that upwelling. I was also wondering if there was going to be an eye wall replacement cycle, like we know it tends to happen in these very powerful hurricanes. But thinking about the ocean, I also was expecting that upwelling, right? But like you just mentioned, like, sure, there is upwelling. So you have very strong winds, they are mixing these water and bringing relatively cooler water from underneath the ocean surface upwards. But when you have such a deep layer of very warm water, what you're bringing back to the surface, it still is very warm water. It still is a lot of fuel for the hurricanes. And so I think that in part may explain why we didn't see a weakening with Hurricane Melissa, even though it was essentially sitting over the same waters and steering them. But yeah, I think so. In my understanding of like how the atmosphere and ocean communicate in hurricanes, we tend to think only about the ocean surface, but it depends also like how deep the very warm water is, like Brian McNulty mentioned in this case.
Right. Yeah, I'll have to look at a couple of days, see if you can sense the temperature difference there. I'm guessing it'll be very minor from what we saw. The only other thing I guess it could be going on is there that every other condition for an intense cyclone was peaked out because we were right at the Carrie Emanuel's potential. I rarely see storms get that close. Dorian's another one.
Yeah. So it's interesting. In recent history, right, there have been many hurricanes that have undergone rapid intensification, and many of them have had just prime conditions. Like Hurricane Melissa is one example. Another example that comes to mind due to its impact in Puerto Rico is Hurricane Maria in 2017. These hurricanes are just being able to tap onto the most ideal conditions for their intensification. And then it's almost like it's very concerning. It's very, like, to me, it's very fearful that if you have a hurricane nowadays, more than likely the ideal conditions are going to be there for intensification. It doesn't always happen, but we've seen it happen very often lately.
Yeah, and I think I'm just amazed at how far we've come. I mean, when I was at the helm there at the Hurricane Center, the statistics said we don't have a clue on how to forecast rapid intensification beyond reacting to the initial start of it and getting maybe the first 12 to 24 hours in there. Now I often see in their forecasts and the discussion backing it up, a period of rapid intensification expected, and it's 2 days down the road, and it happens. So obviously, the improvement in intensity modeling is great. Do you work any in that area, the modeling?
I do. So I use modeling in my work quite often. I mostly use it for understanding. So I'm not in the area directly improving the models, but I use models, especially use the model for prediction across scales, or MPAS for short. It's a community model. It's kind of like the follow-up model from WRF, which many of our listeners, I'm sure, are familiar with. And so I use the model primarily to understand the physical processes that drive things like rapid intensification or extreme rainfall production in hurricanes. And so in my work, for example, I have used models to understand how tropical cyclones intensify when there is vertical wind shear. So we tend to think moderate to strong vertical wind shear, say something like 10 knots of vertical wind shear. We tend to think, or we used to think, I would say 10 years ago or so, that was bad. But then again, nature again and again gave us many examples where hurricanes would intensify, even though there were 10 to 20 knots of vertical wind shear. And through that work, we learned that the three-dimensional distribution of water vapor is very important. So it's not just how much shear there is, but it also matters how warm the ocean temperatures are, how much dry air there is, if any. And so that information has been used in the community for the development of parametric models, not only inspired by my work, but other work as well. And I would like to credit that work that has been done over the years, not just my work, but many work that has been done over the years, looking at what are the ingredients that support rapid intensification, and are we representing those ingredients properly in our models. And so I think I would like to credit some of that work into allowing us nowadays to detect, or not just detect, but like predict well in advance rapid intensification cases. I also worked a little bit. This is not work that I led, but work that I contributed to, using also the MPAS model to look at different flavors of rapid intensification. My colleague Falco Yu, he termed them a marathon versus sprint. So we can have different rapid intensification cases, the marathon being, well, like the marathon analogy is a rapid intensification, but it's gradual and lasting, and it tends to last also, like those hurricanes that rapidly intensify kind of following that marathon do tend to stay very powerful for very long amount of time. But then we have the opposite, which is sprint, which, like the analogy again from running, it's a rapid intensification that happens very quickly. And then maybe afterwards the hurricanes may still stay strong, may quickly weaken. But in that case of the sprint rapid intensification, that is very difficult to detect and to predict by models, and even by statistical models like SHIPS. I would say those kind of the sprint rapid intensification are very difficult to predict just because they happen so quickly, and often they involve multi-scale interactions, one vortex becoming the main vortex and the so-called vortex reformation and many other processes coming into play. So
Yeah.
anyway, that's just to
You get down into the storm scale structure and the eye wall, right?
Right, yeah. So that's where a lot of my work has focused, on the storm scale and the eye wall, as well as like these so-called asymmetric distribution of convection. So when hurricanes are experiencing vertical wind shear, or even when they are very weak, they don't look like your archetypical textbook hurricane, right? You may have a lot of convection all displaced to one side of the center. And one of the most fascinating processes in the atmosphere is like how you get all of that asymmetric convection to organize into what we know as the canonical hurricane with its eye wall and rain bands.
Yeah, Melissa would be a great case study to look at that. It was garbage until it wasn't.
Right? Yeah.
Well, I've been hogging all the talk as usual. So, Tim, I'm sorry, it's your turn.
No, it's all good. It's all good. These are great questions, and I enjoy them. Just a couple of follow-ups on some of the things you were talking about. Then we'll do our mid-show break. Talk about all the deep water south of Jamaica down there. How much of that do we think is climate change induced, and how much of that is just lack of activity in that area so far this year? There just hasn't been anything to go through there to create any upwelling, so the deep water could just build. You put a storm there now, you may have a completely different outcome. Would that be the case?
Yeah, that's a good question. So I personally tend to be careful on attributing any single one event solely to climate change. I do recognize and I do emphasize that our climate is definitely changing. Our oceans are definitely warming, and they are fueling stronger and more impactful storms. But to attribute any one single storm just to climate change is very difficult, because like you mentioned at the example of upwelling and the deep ocean, there's many other factors that could come into play. So I think your thinking is very reasonable. I think, one of the puzzling questions about this season is the lack of activity, right? We were expecting a hyperactive hurricane season, and in terms of numbers, it didn't pan out to be quite like that. In terms of accumulated cyclone energy, it probably it's a hyperactive season. But yes, there wasn't much activity in terms of cyclonic activity there. So that could have been part of the reason why there was not much upwelling, why there was such a deep pocket of very warm water. There are other scientists studying what it's called marine heat waves. So like what happens in the atmosphere and the so-called heat waves, right? You may have a prolonged period of very warm, hot temperatures in the atmosphere, and we all have experienced that to some extent over land, but that can happen over the oceans too. So something that scientists, for example, at the University of Puerto Rico at Mayagüez are studying what causes those marine heat waves, which are essentially pockets of very warm water and not just very warm at the surface, but very warm over a deep layer. And one of the driving factors of those marine heat waves is obviously the winds, but not just winds from the hurricanes, also winds from, say, the Bermuda High. That is one of the factors that scientists at the University of Puerto Rico at Mayagüez are finding that are important. So how strong the Bermuda High is may then dictate how strong the easterlies or the trades are over the Caribbean, and then that may also explain in part marine heat waves. So yeah, what would have been the outcome had there been more cyclonic activity is one interesting question, but another interesting question is what's happening with the large-scale atmospheric system, including the Bermuda High and other synoptic scale systems that are typical of the hurricane season. How were they behaving this year and how they may have impacted what was happening over the Western Caribbean?
Each answer leads to about 20 more questions, so this is fascinating. I appreciate that. But I do want to go back because I just wrote a couple things down during while we were talking with Bill. Go back to rainfall. Does the old rule of thumb, and again, it's just a rule of thumb, still apply? Do we still think that, divide 100 by the forward speed of the storm, get, rough number of inches, 100 divided by storms moving 20 miles an hour, we get 5 inches of rain. It's moving 5 miles an hour, we get 20 inches of rain. And how, is that accurate as a rule of thumb for flat terrain like where I am in South Texas or where Bill is in Houston, but not for Jamaica where there's mountains?
Yeah, as far as I'm aware of, I don't think that old rule of thumb no longer applies. I think we've come to realize that the processes are a lot more complex. The translational speed is definitely taken into account into prediction of how much rainfall there's going to be. But the latest work I've seen, some work, for example, by Kerry Manuel and colleagues, and some work coming out of Princeton University, they do take into account not only the translational speed, that's one factor, but they also take into account the intensity, the vertical wind shear, how much vertical wind shear there is also another factor that they take into account, and the topography. And coming back to vertical wind shear, that's one area where I specialize and one area in which I'm doing some work because we tend to think, again, vertical wind shear is bad or vertical wind shear impacts hurricane intensity here and there. But vertical wind shear can also displace the rainfall away from the hurricane center. So applying from the center of the hurricane, so applying an old rule of thumb, a number divided by the translational speed would not give us an accurate representation of how much rainfall may fall in a hurricane that is experiencing, say, 10, 20 knots of vertical wind shear. In fact, some of my work is showing that when you have vertical wind shear, because of the displaced hurricane vortex, you do tend to get stronger lifting, so stronger rising motions, and then that can cause stronger rainfall rates and more rainfall falling to the surface. So yeah, I would say it's a little bit more complex than just dividing a simple number by the translational speed.
I always knew that was too easy. Too easy. Absolutely. Okay, Bill, let's do it.
Nice, right?
Yeah, right. But that's what you're studying. That's what makes this so interesting. Let's take our mid-show break, Bill. Let's do a tropical update. Then we'll thank our sponsors after that, and then we'll get back to some more questions. So, Bill, tropically speaking, we know what's going on, the main thing, but what else?
Sure. I want to touch one little item there. The interesting thing that you had on the shear displacing it from the center. If you look at the rain of Harvey, the heaviest rain were in these outer rain bands, and they were being enhanced by wind shear and really good outflow up at the top of the troposphere during that. So that's a good point that a lot of people forget we have. So I'm going to try to share a screen here, and I'm sure everybody's sick and tired of hearing about Melissa except us weather weenies, but that's what we're going to get. Otherwise, I wouldn't have anything to talk about. This is the history up until 12Z this morning of Melissa. We had Dr. Phil Kotzbach on a couple of days ago, and a lot of discussion about the absence of anything in the Caribbean, and he very cleverly pointed out lately we've been having these late October and even November storms go nuts in the Caribbean, and this was a pristine environment for it, and give him a star for that. And then it moved slowly, very slowly, as it came into the Caribbean after a rapid race on the open Atlantic, and it had the unfavorable environment until it got to the central Caribbean, and then it got its act together. It took it a while, but once it finally consolidated around a clear cut center, it went through a prolonged, actually, period of rapid intensification until it maxed out, and then like we were talking about earlier, it chose not to be bothered by upwelling or those bothersome eye wall replacement cycles, and became one of the top 3 or 4 storms to make landfall at that strong a Category 5 in Jamaica. Yesterday, started moving finally at a reasonable clip, and re-intensified a little bit until it reached Cuba a little after midnight, I guess, this morning. And now it's getting ready to come out into the Bahamas, into a Category 2. And one of the old analysis tools back before satellites is wherever you don't have observation, that's where the hurricane is. That's where we are today. I'm sure the power's out for the folks here. Kingston stayed up, but nothing on Montego Bay or other sites there. In there, so we have a dearth of surface obs in that realm. Radar out of forgot the name of this site. I don't see it. Okay, it's the one on the point here out of Cuba. Did stay up, and we've got a nice long loop from Brian McNulty on there that captures the landfalls both in Jamaica and in Cuba on the radar. So here we are this morning. See if get that thing updated. It's supposed to automatic. I did something wrong. Okay. The center now is off of land and is pulling away from Cuba. And I guess there's a little debate whether it'll reorganize much more than it is now after getting fairly well disrupted. It has grown in size as they do both from the land effect and from the gaining latitude. On the visible satellite, see if we can see anything. The eye had filled, and it looks like it's still filled with clouds in the center there. It'd be very tough for me to make out any real eye wall in the system there. Hurricane hunters are out there. It was a testament to how violent, if you will, the center of Melissa was at the Category 5 state. Both an OAP3 2 days ago and then a C-130 yesterday exceeded the specifications for stress and turbulence and had to return to base as a safety caution. I didn't hear anything adverse happen to the airplanes, and they made it back. So hopefully we don't have any problems with the airplanes that connected with that. But you can see in these outbound legs, the hurricane force winds have expanded outward on the east side quite a bit. And let's see what there. The pressures are in the 970s. Winds are a lot less than at flight level, at least showing a lot less than you'd expect for the velocity they were carrying in the last advisory. As far as what's going to be happening to it, the water vapor loop here shows that a very deep trough digging southward in the eastern U.S., inducing quite a bit of westerlies, and the combination of the shear and the development of the steering current is going to move Melissa at progressively faster speeds going northward, and it'll probably become one of these asymmetric circulations that Rosimar was talking about, with most of the convection being displaced to the east and a strong wind field all around it. And then it'll eventually go extratropical. Bermuda's kind of in the path of it. Let's see what they've done with the forecast in there. There's Bermuda's where the red dot of hurricane warning is going to go very near Bermuda, still as a hurricane, and then after it leaves the warm ocean and gets deeply embedded in the jet stream flow, it's going to go extratropical and contribute to a fairly intense extratropical low heading off into the North Atlantic. The rainfall, again, it's starting to move faster, so the 20 to 30 inch forecasts that we had before are not there. We're talking in the Bahamas, and until it gets away from Cuba, the remaining extra rain still up to a foot or more in some isolated locations. For those of you that wonder what next, there is nothing for the Atlantic and Eastern Pacific, really. This is from the DeepMind model, and its ensembles. It shows quiet there, and all the action's going on over on the western side of the Pacific for at least the next 10 days to 2 weeks. The CPC outlook for the tropics, they keep an area of some risk down here in the Northwest Caribbean, both in weeks 2 and 3. Combination of stalling out fronts in there and a still present Central American gyre appear to be the main reasons they're looking at the potential exists there, but nothing going on at the current moment that we're looking at. So with that,
one big bad storm. That's what we got to talk about.
Yeah, that's a very fascinating storm.
Let me thank the sponsors, then I'll come back with a follow-up for both of you guys on the list in particular. So the sponsors, USAA, and Bill, you're an endorsement for them. We appreciate that because we know that you're a customer and have been using them for a long time, right?
53 years.
That's about as good as the endorsements can get. So thank you, Bill, and thank you to USCA for all you do. The South Padre Island Convention and Visitors Bureau, that's the home of the National Tropical Weather Conference. We'll be there in April. Plans are well underway for that, so be watching the website for registration information so you can come join us in person if you'd like. The Weather Company, they provide a lot of the weather graphics that TV broadcasters around the nation use, and they're a big part of this as well. Weather Boy, they sponsor college students to come to the conference. It's a contest. It's just a contest. You enter the contest if you're enrolled in a meteorology program in any meteorology school in the United States, continental U.S., or Hawaii. You can enter and perhaps win a trip and come sit across the table from Bill Reed or anybody else that's there and learn a lot of cool stuff. And LiveView, they're the ones that make the live broadcast possible from the conference back to everybody's home market. So if you're watching from South Carolina, from Louisiana, from Florida, whatever, your local broadcaster is using LiveView to get that signal back to you from South Padre Island. Okay, following up on Melissa, it seemed like, the Google DeepMind model did a good job. I remember last week I was sitting here with Mark Sudduth talking about it, and we talked about how it was only going to move about 300 miles in a week, and the models were pretty good about it. GFS not so good, but the Google DeepMind, some of the others did a pretty good job on it. What surprised you? Let me ask you first, Bill, and then Rosimar. What surprised you on what happened with this storm? It seemed like, again, it behaved relatively well compared to what the forecast was.
Actually, not a whole lot. What surprised me is a function of how long I've been doing this. I'm always amazed these days at how well our computer models are doing, and what an amazing tool that gives the hurricane specialists for being able to say with confidence what you're going to get. I mean, 12, 13 years ago when I was working there, I don't think we would have had that confidence in what we were putting out in the forecast when it was only a couple hundred miles from Jamaica.
Well, the fact that it sat still and that was forecast for so long, and then it was going to eventually move, and the whole thing was pretty amazing. Rosimar, the same question to you. What about this storm thus far? Is there anything that surprised you, or has it been just really well behaved?
Yeah, so just going back in time a little bit, about 2 weeks ago, I got a phone call from my parents in Puerto Rico. They were extremely concerned about this system that eventually became Melissa, about possibly impacting Puerto Rico. So I would say like I agree with Bill that our models have become like a long way. I think there's still like quite a bit of uncertainty out there before the storms develop. And so I'm obviously thankful to Mother Nature that it did not pan out to like cross Puerto Rico. Unfortunately, it did cause a lot of damage in another island, and my heart goes out to them. But just going backwards in time, I just remembered that, that the models were hinting at something developing, but they were not quite right where it was going to go. And that's what I tend to tell my folks back in Puerto Rico, like stay vigilant, but we're not very like certain about what's going to happen until we have a well-formed cyclone. Then going forward a little bit on time, before the models had like settled on the solution of stalling near to the south of Jamaica, there was quite a bit of uncertainty on whether the storm was going to go over Haiti, even over Hispaniola, or if it was going to even like veer a little bit southwestward, which would have been like an odd scenario, right, for these like regions. So I was watching closely because there was a lot of uncertainty there. So I would say like, I think once certain stars aligned, it was a well-behaved storm, but before those stars aligned, there was a little bit of uncertainty or quite a bit of uncertainty. Now, what are the stars that align? That's what a lot of us are going to be wondering over the years and studying.
Yeah. Do you think maybe there's an upper limit scientifically on how far out we can forecast these beasts?
That's a good question. There is some work showing that maybe we cannot predict these beasts longer than 2 weeks out, but I would say there's probably a limit to the fine details. For example, the intensity, like how strong a hurricane is going to be. I think that's going to be very difficult to predict weeks in advance, primarily because I am of the thinking that the intensity is governed by many factors, including many like microscale factors like at the cloud level, right? And that's going to be very difficult to predict ahead of time. We'll see what the future holds with tools like artificial intelligence and machine learning. But I think that we can at least have a longer limit in terms of likelihood, in terms of probabilistic forecasting. For example, some of my work looks at the influence of convectively coupled Kelvin waves. They're kind of like a cousin of the Malin-Julian oscillation, or the MJO, which probably a lot of our listeners are more familiar with. But the convectively coupled Kelvin waves are these disturbances that travel worldwide along the NTWC. Past work by Carl Schreck, Mike Ventures, and others had shown that whenever you get a Kelvin wave going by the Atlantic or the Pacific Ocean, you may get an uptick in tropical cyclone activity. But in that work, it was very difficult to disentangle how much was due to the Kelvin waves, how much was due to the MJO, or due to interannual variability like La Nina. But in my work, I designed some modeling experiments in which we only had Kelvin waves. We did not have La Nina, El Nino. We did not have the MJO. And my work did confirm that after 2 to 3 days after Kelvin waves goes by, place of active convection in the tropics, you get an uptick, an increased likelihood of tropical cyclone activity. So I think as we learn more about these multi-scale processes, I think we can extend the range of our probabilistic forecast of saying we might expect a very active week. Let's say next month, we might expect a lot of hurricane activity within a season. But in terms of like predicting exactly like how strong those cyclones are going to be, I think the limit is shorter there.
Yeah. Yeah, well, yeah, if you find something like, again, isn't part of the problem is that if the Kelvin wave is important for forecasting development, now it becomes important to forecast the Kelvin wave. So you're back to the same set of problems of how much skill can you have with knowing initially you come out with incomplete data set to initialize it to run it out that far in time. That's a fun problem to have now that we've actually found tools that help us get there, I think.
Right. So now as we move more towards global modeling, and even now with the advent of AI modeling, some work that is being done by my colleague Quinton Lawton at NCAR, he's finding that one of the ECMWF AI models actually can replicate the structure of Kelvin waves with great fidelity. So that tells us something about the imprint of these waves in the large-scale circulation that then can be used through reanalysis data to inform these AI models to predict Kelvin waves. And maybe that can also inform numerical weather prediction model improvements. But you're right, like if we want to be able to exploit that relationship between Kelvin waves and tropical cyclones so that we can use it to inform like emergency managers and communities about active weeks of tropical cyclones within a season, then we also need to be able to predict well the Kelvin waves and other phenomena.
Yeah, that's the important stuff for us to know. The ability to at least give these folks an idea of where to look for that. There's not a whole lot they can do 2 weeks in advance other than be ready so that when something develops, to pull the trigger on all their actions. And heck, when I first started out, the tropical weather outlook was a 2-day forecast, and it was a text. It was just a subjective conditions look right for nothing, kind of like 2 days. And now we're out 7 days on that. So I'm actually fairly optimistic on the probabilistic type of forecast going farther out in time that will make gains. And I don't understand AI, and I've tried, but I do understand that it works. I've watched the results of it, at least for certainly for the track forecasting. The several examples we've been able to follow, it just amazes me.
Yeah, it's certainly a promising tool. I think one of the roadblocks is that a lot of these AI tools are being trained with very coarse resolution data sets, and that might be one of the reasons why they are doing really well with track, not so well with things like intensity. But I'm hopeful that maybe in the future we're going to see tools that are developed, maybe exploiting satellite data that contains a lot more details about hurricane structure, maybe using the wealth of hurricane aircraft reconnaissance data. And maybe those tools can help us also with improving prediction of intensity.
Yeah, as I understand it, it's very much a pattern recognition type technology, and the satellite imagery to me, you look at the Dvorak technique, that is pattern recognition. So
right.
By the analog folks. But a question on a storm that is near and dear to you, Maria. I distinctly remember the horror in Jack Bevan's voice when it was east of Dominica, and it went. His forecast was for it to steadily intensify and maybe make Category 2, and it went ballistic on him with the pinhole eye and all. Do you have the opportunity to go back and retroactively look at some of the work you're doing with those storms like that were problematic for us?
Yeah, some of my work is looking back at cases that were difficult to predict and trying to understand what could have been done to improve their prediction. It is in my very long to-do list to go back to Hurricane Maria for different reasons. I haven't done it yet, but several questions that come to mind with Hurricane Maria, for example, is that like you mentioned, it rapidly intensified, became a Category 5 hurricane when it was first anticipated to be Category 2. So the lingering question there is like what happened, of course. Something that was very intriguing to me was, like you mentioned, this pinhole eye. So the eye was very small, and when it went over Dominica, it almost raised the island north-south. So it didn't like quite cross the island and just like that, right? Like it was going over Dominica, and then like the eye, like this is very subtle. So the advent of like very detailed and very like high spatial resolution, temporal resolution satellite image allows us to see that. But because we were getting so many frequent satellite images, you could see that as Hurricane Maria like touched down or made landfall in Dominica, it didn't just cross into the Caribbean, it kind of raised the island north-south, and then it left. And even though it's something very subtle, something like that makes me wonder what the fate of that small change in the track was in terms of how then Hurricane Maria ultimately made landfall in Puerto Rico. Another research question I have with Hurricane Maria that I haven't been able to go back to it yet is that just before it made landfall, it underwent an eyewall replacement cycle. And as we know from past work and many years of satellite data, is that when these hurricanes undergo an eyewall replacement cycle, the wind field tends to expand. And so how much of the destruction and the devastation that was caused in Puerto Rico was because of these eyewall replacement cycle? And, it still is very difficult to predict. Even nowadays, when I read the forecast discussions from the National Hurricane Center, there's always the mention that perhaps there's going to be some intensity changes due to eyewall replacement cycle, but they are very difficult to anticipate. So those are some of the lingering questions I have with a case like Hurricane Maria, but I haven't had a chance to go back to that case yet.
Yeah. Irene would be another one I'd love you to look at, because we expected it to, there was a area of warmer than normal water in the Bahamas, and just north of there, it did the ERC over the Bahamas, and the anticipation was it would regroup and hit the Outer Banks of North Carolina as a Category 4. Obviously, that didn't happen.
Right.
And I don't know if we ever figured out exactly why that was, or obviously we didn't have any tools then that could forecast it for us.
Right. Yeah. And I lived through Hurricane Irene when it went through Puerto Rico. And I also remember as it was going through Puerto Rico, it was tropical storm. But then as it emerged north of Puerto Rico, then the National Hurricane Center upgraded it to a hurricane. And there's still some lingering questions there as well as to how much did the island impact the hurricane, or did it even things like orographic interactions, did it help it intensify even? Yeah,
but normally you expect it to disrupt it if it's already weak. So my guess is the environment was perfect, so that once it left the disruptive terrain, it took off. If I remember correctly. Yeah. Tim, this has been great. She and I have common hurricanes of interest.
I love this. I can sit back and listen to you guys all day. We are coming up to the top of the hour, so let's get to the end of the program. And Bill, well, let me ask Rosimar first. Where are we headed? We've learned a lot in your studies. You've learned a lot. All the things you've done. Where are we headed from here? What's in forecasting and intensity changes and things like that? What do you think's next?
That's a very great question. I still think the problem of rapid intensification is an issue that we're going to be studying for years to come, because even though we're getting better at it, there are still many cases that, just like the example of Hurricane Maria, right? There's many cases that test our ability to predict them. I think so, at least where I personally am headed is to understanding better what factors control how much it rains in a hurricane, and how those factors may change in light of a future warmer climate. I think rainfall is a very impactful effect of hurricanes, and we know from many years of unfortunate events that water, not wind, is the leading cause of fatalities due to hurricanes. And it's not just freshwater flash flooding, but also storm surge. Also, when you get the compound effect of flooding and storm surge, right? But rainfall is a very impactful effect of hurricanes in predicting how much rain is going to fall at a particular place and what the downstream effects of that much rain might be to landslides, to flash flooding, to river catchments, etc. It's very important for society. So at least in my work, that's where I'm headed next.
We've come a long way, and thanks to all the work that you've done. We appreciate your studying and your hard work and your diligence in making this work. Bill, what have we learned today?
Oh, lots of things. I just tie all the ends that she just talked about together there. I think you all in the media world and us in the forecast world have been trending our focus into forecasting the impacts, and everything that Rosimar brought up are areas that we need improvement on. The rainfall aspect, obviously, we make great gains, but we sometimes miss it. The storm surge, we're making great gains, and it's tied to, you have to have the structure of the storm right to get the storm surge forecast correct. So there's a lot that we need to keep working on, but I like the direction going.
Terrific. Bill, thank you. Dr. Rosimar Rios-Berrios, thank you for your time today and for all the work that you've done. And we look forward to hearing more from you in the future as to what you continue to do. Thank you so much.
Thanks for having me.
We appreciate it. Let's thank our sponsors who make the program a reality week in and week out. USAA, the South Padre Island Convention and Visitors Bureau, the Weather Company, Weather Boy, and Live View. I don't know what y'all have planned for your day, but Bill, I'm worried about you because all through this program, we've had two lovely ladies putting witch hats on behind you. So it worries me about what the rest of your day is going to be. But I wish you the best with that.
You never know, man.
Hey, coming up next week, George Siegel's going to be with us. He's done a documentary called The Last House Standing, which explores the fact that most people think catastrophic destruction will never happen to them. We'll talk about that next week. Until then, take care. Have a great week. We'll see you next week.